Hello everyone and welcome to part 6 of my series about vSphere with Tanzu. Today we're going to show how it looks in NSXT when we are going to deploy some pods and a deployment and see what we get initialized in terms of objects in NSXT. So I'm going to deploy workloads in my alpha namespace. And we're going to start with an example of a Busybox pod, just a simple example. One pod in a file, a Busybox image in the namespace alpha. I will try to fetch the image from the Docker image registry. If that isn't working, I'm still able to fetch the image from the embedded hardware registry. That's why I have this comment here. So bear with me, I will talk a bit later about that as well. So let's get started. So first of all, I need to log in the environment as the alpha user using the alpha namespace. Then I have to make sure I'm using the right context. And now I should see all current objects in this namespace. So there are no pods yet. So I have prepared a directory where all my deployment files are. So let's do a kubectl apply, and then I think we have the Busybox pod YAML. This will deploy one single pod. So kubectl says the Busybox is created, so we can do kubectl get pods. So we now see a pending, and we should see in vSphere that it's trying to deploy a Busybox pod. According to vSphere, it's already running, as you can see here. And it's running. So if we do a kubectl describe pods and then the Busybox pod, we get information about how we can troubleshoot and get information of the deployment of this pod. So what I wanted to show is that in this case, the image controller was ready to have that image already running and is able to start that image. In some cases in my lab, I've seen that I was faced with connection rate limits on the Docker image registry. So if I'm trying to deploy a new image which I never deployed before, I would most likely will not be logged in from a vSphere point of view into the Docker image registry, and it will notify you. And you can find that error in when you do a kubectl describe. So in this case, the image is already cached and is ready to run. So let me now delete the pod again. And all right, so in order to use the image registry, I need to uncomment this line and comment this line. So I've already prepared the Busybox image in the hardware embedded registry in the alpha project as a Busybox repository. Save this, wait for the command to be complete. So you can now see the Busybox is being stopped and it will be removed, and it's gone. So now we recreate the Busybox pod. Again, in vSphere, You see the pod being started as well, and it seems to be running already. From kubectl, it's still pending. And it's running. All look good. So let's now have a look what's happening in NSX. So I would always like to recommend to start with the inventory containers page. So we know we use the alpha namespace. So as you can see here, in the alpha namespace, we now have one pod running. If I click on that pod, you would see in NSXT as well that it's able to identify the name of the pod, the container node on which the pod is running, and the IP address being allocated for that pod from the IP pool in this namespace. And it's also able to identify the segment and the segment ports being used. And it's up and networking status is up. So let's move a bit further with this example. So now I want to show a deployment example and what happens there. So let's let the Busybox pod running for now and show what it looks like if we want to deploy, let's say, a bunch of NGINX web servers in a given namespace. So I have a NGINX deployment file prepared, YAML file prepared in the alpha namespace. I'm going to match labels, NGINX. I'm going to declare 3 replicas to make sure we have 3 pods running. And I'm fetching the image from the embedded Harbor image registry. Obviously, I've already prepared the Harbor project for this and uploaded an NGINX image. So let's do kubectl apply -f and then NGINX deployment .yaml. All right. So we should see in vSphere now a number of pods being deployed. Yes. 3 NGINX deployment VMs are being created, or containers are being created right now. And you can see slowly, one by one, they are being started. And at some point, they should be completed running. Don't mind this single pod not being started. That's a previous attempt which got stuck, so I have to troubleshoot that. That's a different video. But in this case, we already see that we have 3 NGINX pods being deployed. So let's do kubectl get. Well, forget all. Actually, that's a good example. We now see 3 pods in status running, 3 NGINX pods, and we also see the deployment being ready. So we have 3 out of 3 ready, 3 up to date, 3 available. So this looks great. Let's see what happens in NSXT. So in NSXT, if we refresh this inventory, containers inventory page, we now see 4 pods running. Again, for each pod, NSXT is able to identify the details of the pod, the name, the container node it's running on, and the IP addresses being available for that pod. Also the segment and the segment ports and the labels. As you can see, we specify the label NGINX, so it's able to retrieve the labels and to show you the labels in the containers inventory page, which is very useful if you need to search in a bunch of objects. So given the fact that each namespace starts with a single segment with an IP pool with a /28 IP subnet size, we have only 14 usable IP addresses in that given IP space. So what happens if we are going to have a deployment and say we want 16 pods? Well, in that case, NSX will automatically scale for you and will attach multiple segments for the amount of pods you require. So let's test this. So let's quickly go to back to Visual Studio. And now we're going to change the number of the replicas to 16. And we're going to apply again this deployment YAML. So now we should do a rolling update of the deployment, which means that it should scale automatically. So you can see now it's starting a lot of Nginx new pods, as I will show you in vSphere. So you can see a lot of pods are being created and being started, and slowly but steadily the deployment will update its state. Currently it's only 3 out of 60 ready, up to date 16 available free, and this number should go up, as you can see right now. And in the background, obviously, a lot of things are happening, right? NSXT objects are being created, ports are being bounced to the containers, images are being started or fetched from the embedded harbor image registry, being started from vSphere. And once they are ready, kubectl will update the deployment. You see the numbers climbing. Already 13 out of 16. 14. 16 pods, 16 up to date, 16 available. So now all the pods are ready. And you can see that the pods have been allocated IP addresses from the IP pools being allocated to this namespace. So with this command, you can see obviously the IP addresses, but also the nodes on which they are running on. And you can see that they are having different IP subnets as well. So let's have a look how that looks in NSXT. Again, starting with the containers inventory page, we see the alpha namespace, and we now see 17 pods running, one of the Busybox pod and 16 of the Nginx pods. NSXT again is able to display all the information related to this Nginx deployment and the Nginx pod names. And you can see all related IP addresses and all related segments and their segment ports. All good. You can also see the networking number will slowly come up or go up because we now have, instead of one, we have 2 IP address pools being allocated to this namespace. So NSXT automatically scales out in terms of required IP address pools if you need more pods in a given namespace. Now, obviously, we now also see 2 segments, which means that this new segment being created for the additional pods is automatically attached to the tier 1 gateway for this namespace, and will make sure that we have distributed routing between pods in that given namespace. So now we have these 17 pods running. Let's see what happens if we scale back. So now I'm going to enter 3 replicas, apply the deployment file again, and we now should see that the deployment automatically scales back. And what I've seen so far, it does it in an intelligent way, in the sense that it's removing the pods, but will also remove the pods from the extra added segment, so it can also automatically delete the objects in NSXT, which we don't need anymore. So now we're back to 3 running pods for the Nginx deployment, and we should also see that being reflected in NSXT. So 4 pods remaining. It can take a bit longer for the segments and IP addresses, or IP pools, sorry, being removed, which are now not necessary. As you can see, It is very clever because it only removes the pods running in IP addresses from a new IP pool. So now we can see it has consecutive IPs running, and you would also see the networking objects being deleted later, but this can take a few minutes before they are being deleted. So this concludes this demo about vSphere with Tanzu, about pods being deployed and a deployment with pods being deployed. Thank you so much for watching. I hope it makes sense and you liked it. And until next time, bye-bye.